First, let's run the program to see how it works. So you need to enter the numerator. Let's put a 6. And then you put a denominator. Let's put 16, for example. And you end up getting 3 over 8. 6 over 16 can be reduced to its lowest terms. So you get 3 over 8. Okay, it's a very simple program. Let's just see how it works. Look at its coding. So let's make the stage smaller so you can have more space on the coding area. Now again, if you like to pause and just look through the code to try to understand yourself, please do so. Let me explain here. If you first you click and I set up all this variable to be 0. Now here I use 5 variables. There's a common factor I use to divide by it on the numerator denominator. Later I explain later one more time. And then numerator denominator just accepts the two whole numbers to that's gonna become the original fraction. And then the L numerator, L denominator is the two whole number that hold the final simplified lowest terms, one for numerator, one for denominator, as you can see on the stage. And then after that, after you set up all this to 0 and you set as common factor to initial to a 2, is because if you want to simplify all this, just cancel the common factor, you start from 2, right? And then start from here, after you accept these two numbers, and then I will give the numerator to the L numerator and then give the denominator to L denominator, because I'm not going to change the numerator denominator. I want to show it on the stage, and then you can compare what's the final result to the original. So the final result of the numerator is going to be stored in L numerator, and the final denominator is stored in L denominator. Okay, now here is the key process. You have to use a loop. There are a lot of loop. If you look at the control, you can see there are a lot of way to do loop. You can repeat until which is the one I'm using, and you can wait until forever if something like that. Of course, if you know how many times you're gonna repeat, you can use this one as well. Repeat, you can change the number of times to repeat. Now here I'm going to repeat until the common factor is bigger than the numerator. Okay, so this is we have to take a look at step by step to understand why we have to do this way. So let me put this one here. Okay, put this one here. I think it's the wrong place. Yeah, put it here and then we can see after each time we divide by the common factor and what kind of result we can see. Okay, now first of all, let's come back to run this program again. So this time let's put bigger numbers. Let's see 32 for the numerator, and then 124 for the denominator. So this time you can see first I divide by 2 because both numerator and denominator they're divisible by 2. They're obviously, and then after divide by 2, see each one gets cut in half, right? But this one this time 16, you got 16 over 62. They're both still divisible by 2. So in this case, I should divide it by another 2, right? So, and then if I press, I added this sentence is just to pause and let you see the result right here. So if I press return, and then you're gonna see the next step. Okay, and after the second time, actually they're divided by 2 one more time. So it was 16 here, now it becomes 8. Was 62 here, and now it becomes 31. And if you press return again, and they're gonna try to find another one. See, so this time if you show the common factor, and the common factor I didn't show it. So if I come back to here and show the common factor, right? Common factor, you can see now I'm gonna use 3 to try. And obviously the 3 is not divisible, but I don't know, the computer doesn't know, and we have to try. So we use 3 to try, and there is a way to see if 3 is divisible by each. And then I just press, oh, it looks like we have to do it over again because I changed something. So let's see, 4 divided by 12, right? So you can see first it becomes 2 and over 6, and you return and you do one more time, it becomes 1 over 3. And if you press again, and it just stop. Okay, so let's take a look at the code, why we have to take multiple steps and when it's gonna stop. Okay, let's switch to small stage, and here you go. Repeat until the common factor is more than the L numerator, and the common factor was initially set to 2, and then each time if we let's just say if it's a 2, and then see if the 2 is divisible by each, right? So the way to check if the first common factor is divisible by numerator and denominator, we simply use the mode. Okay, we saw this mode operation before. So mode is actually to find a remainder of a division. So if we use the numerator divided by the common factor, and then we use mode, is to check if it's divisible. And then if it's equal 0, that means it's divisible. And then check the denominator divided by the common factor. If it's after the mode operation equals 0, again it means the denominator is divisible by the common factor. So basically, if both numerator and denominator are divisible by the common factor, and then this is true, right? If this is true, what we do is we actually just divide the numerator by the common factor. So then the numerator is gonna becomes the quotient of this division, right? So for example, 8 divided by 2 would become 4. Now the numerator would become 4. And then the denominator divided by the common factor, and then it's gonna be maybe if it's 12, now it becomes 6, right? And then if it's divisible, we're not sure if there is another same common factor. It's very possible. So in this case, we are not going to change the common factor. Okay, so we're gonna just let it go, and then just come back here to try this one more time, right? If it still can divisible, we're gonna do this again. Sometimes you can divide by 2, for example, multiple times to reduce a fraction. And then what if it's not divisible, and then we are not sure if it's not divisible by 2, maybe it's divisible by 3. So in that case, we simply add the common factor by 1. So then the next term is going to be the common factor, it will become 3, and then come back to here to try see if the numerator and denominator are both divisible by 3. If it does, and it's gonna be reduced one more time. And if you keep adding the common factor, so eventually when the common factor is more than the numerator, now in this case I make the numerator is smaller. So if the smaller number, if the common factor is already more than the smaller numerator, that means we already reduced it to the lowest term, right? There's no way to reduce further. Okay, maybe we can come back to see another example to have a better understanding of this process. Okay, let's try a different number. So this time we try a bigger number. The number, let's include it's a factor of 2 and 3. Let's see, 24 as a numerator. Denominator, let's try use a bigger one. Let's use 48. Now you know the result 24 over 48 is the final result should be 1 over 2. But let's see the process how it does. See, actually it's each one divided by 2 first. So you get a 12, 24. And according to what we just explained, we should have divided by 2 one more time. So let's press return. Here you go. You see 6 over 12. And it looks like it should be divided by 2 one more third time. So let's press. So you can see again it divided by 2. But of course the computer is actually going to try to divide by 2 again, but of course this time it won't work, and then it will actually try to change the common factor. So see, the common factor is still 2, right? So the computer is going to try the common factor 2 one more time. Let's press return. Okay, but obviously it doesn't work, so it doesn't change, and then the common factor becomes 3. And if you press return, it's actually you're going to try divide by 3, and finally you got a 1 over 2, right? And then the computer is going to continue to test if the common factor is more than the numerator. In this case, the common factor is 3, but numerator already 1, so obviously this is already become the lowest term. So the program is going to stop right here. Okay.